Let's say you want to organize these two sets of data in math class. Well, now you can, with set theory. The Venn diagram represents the two sets. The overlapping area contains numbers that are found in both sets. We can begin to analyze the relationships by utilizing parts such as the union, intersection, and set difference.
Whoa. Hold on there, Sam. Let's go back to the beginning. Set theory was founded by George Cantor, a German mathematician living in Halle, Germany. This concept became a milestone for a variety of mathematical studies. In a nutshell, set theory is a way of dealing with formal properties of sets and collecting assorted mathematical objects in order to simplify their relationship.
Set theory has many different uses in many different branches of math, but it's most commonly used in probability, statistics, and geometry.
Here, we have two examples of some of the more common symbols found when using set theory. A U between the titles of two sets resembles the union of those sets, which is a collection of all data from both sets. Similarly, an upside-down U represents the intersection of two sets, in other words, whatever they have in common. These symbols can be applied to collections of 3 sets, 4 sets, or 5 sets, and so on.
Now that you have a better understanding of set theory, let us return to the original problem proposed at the beginning of the video. In set A, we have the numbers 1 through 5, and in set B, we have the numbers 2, 4, 6, 8, and 10. To start us off, we can sort the data points into a Venn diagram as shown here. The intersection is easy to recognize as it's the center of the Venn diagram, while the union is the collection of all the elements from sets A and B. Beware, when writing out the union, do not repeat terms. As you can see, I pulled the elements from both sets and wrote them here as the union, and I did the same thing for the intersection here. Let's take this one step further. Here we have a skeletal Venn diagram. When the diagram is empty, it is referred to as a null set. In set A, we have the numbers 3, 6, 8, 10, 1, and 7. In set B, we have 8, 7, 12, 13, 3, and 14. We start by identifying the similar numbers between the two sets and writing them in the intersection of the diagram. Next, we can sort the remaining numbers into their respective halves based on their original set. Finally, we can write the union and intersection of both sets as a whole.
Did you go? Boop! Before we go any further, I'd like to free market Metropolitan's Market cashews. Go nutty. Now that we have a refined understanding of set theory, we can begin to take apart some of its more complicated components. A bijective function is a function between the elements of two sets where each element of one set is paired with exactly one element of another set. Notice how each x value is paired with one and only one y value. In comparison, a surjective function has at least one x value for every y value in the codomain. For example, the number 1 is paired with the letter D. However, a letter could be paired with more than one number, such as A.
We chose set theory because it looked very interesting, as well as we learned the basics of it last year. What do you think, Jonas?
You know, I agree. And then the project enhanced our understanding of set theory and of sets, because it's called
Set theory, yeah, right.
set theory, right?
Yeah.
I just feel like we understand the relationships between sets a heck of a lot better, and the way that sets interact and how different sets can be described and how we can characterize
And we learned
them.
new vocab, like
Yeah.
like one-to-one sets, and
We just kind of expanded our vocabulary, and we basically now know how to use set theory
yeah,
efficiently.
yeah,
Yeah,
yeah.
yeah.